Oh, forgot to check the input device. Yep, recording from the right device. Different classrooms are different. I noticed in this classroom, the mic is always set up right the first time, and then in room 121, it's always set up in the wrong way. And it's the same type of startup, it's the same operating system, same configuration files. And yet things are different. Oh.
It's the day class. It's the day class.
It's the day class, yes. It's the day and night effect. All right. So let's go ahead and get started. I hope most of you have gotten started with the pre and post condition homework assignment. Kind of? No, I haven't taken a look. I'm so confident I can get it done in time. I'm not going to do it until 5 minutes before due date, right?
Yeah, no thanks.
So if there are any questions about the pre and post condition homework, this would be a good time to talk about it. Do you guys have any questions?
No, we did. We did.
You did? And it's all resolved?
All resolved.
All resolved. Very good. Any other questions? Okay. Yep, go ahead.
Will you talk about the exam today?
Yep, we will talk about the practice exam as well today. Okay, so for the homework assignment, I just want to give you guys one more example that is going to be quite important, okay? It has to do with when you have different ways of expressing equality, when do you need to say, oh, but this also implies that, and actually add it to the conjunction? Okay, so we'll go ahead and take a look at that first, and then we'll talk about the practice exam. And we'll talk about the exam itself in general. All right, so what I'll do is I'm going to give you an example. Okay, this is line 1. Line 1 says x gets y. Line 2 says y gets another constant. Let's say that's n. Okay. Okay, that's it. That's really simple. It's related to the first question in your homework assignment. Not so much the second one, but the first one. I'll give you a precondition of line 1. The precondition of line 1 is I know something about y. Y actually has a value of k. That's it. Okay, I'm not going to tell you anything else. The only thing I know is y has a particular known value, which is k, and I don't know anything about x, and n is just another number. Okay. So what we'll do is we'll go through the derivations that you have to go through as well in your homework assignment. But I'm going to emphasize one thing that I actually did not mention in class, and that's why I am going to give you this particular example. The first thing we want to do is to figure out, okay, now that we have the precondition of line 1, how do we derive the post condition of line 1? Well, we have all those steps, right, to determine which operation to use, either the substitution operation or the forget operation. Those are the only two applicable to assignment statements. So what we'll do is we'll say the right-hand side of line 1, okay, we always start with that because that really determines whether the operation is reversible, and I just call it f of x because it is a function of x. X is the variable on the left-hand side. So this is how we define the function, f of x equals y. Okay, so it sounds like f of x does not even depend on x itself. Okay, it does not refer to the left-hand side. So as a result, f of x has no inverse. There's no way for me to reverse the operation to get back to the value of x before line 1. Is that okay so far? Okay. So as a result of that, we have to apply the forget operation. You don't have to be as wordy as I am here. You can basically just say, inverse function does not exist, use forget operation. Okay, that's fine. Or if you want to use, like symbols, like a left, like a right arrow to say, okay, this implies we have to use the forget operation, that's fine with me. As long as the reasoning is clear, it's fine. Okay, so now we apply the forget operation. The forget operation means the post condition of line 1 is based on the precondition of line 1. We might have to forget something because anything that mentions x, which is the variable getting changed on line 1, we have to toss. Okay, we cannot keep those things around. But in addition to this, we will also know that x and y should be the same right after line 1 executes because it is an assignment statement, y is on the right-hand side, we use that to update x. The next line is really just expanding what is pre1. The pre1 is pretty simple in this case, so I'm just going to copy and paste it here. So no big deal, the second line is pretty simple. The third line is actually carrying out the forget operation. So we look at the precondition of line 1, and then we say, okay, do we actually have to get rid of anything? Does it mention anything about x at all? Nope, doesn't mention anything about x, so we're good. We don't have to forget a single thing, and in this case, we keep y equals k, and then we say x also equals y. So in the previous classes, I'm just saying, okay, this is good, we'll move on from this point. Okay, for this particular homework assignment, if you want the first question or the answer to the first question to be meaningful, you want to do something else. Okay, you want to take this one more step. Because if I can say that y equals k and x equals y, I can also imply that x equals k, right? Because equality is transitive. X equals k, and y equals k and x equals y, using the transitive property of equality, I can now say, x also equals k at this point. Are we doing okay so far? Yep.
Would it be okay to kind of group it, so y equals k equals x?
I would not, I would keep it like this, so each condition would only have, 2 sides instead of 3. And it will be clear why we want to do that, because if you combine, x equals y equals k, when we have to get rid of something, then you might think, oh, we have to toss the entire thing out, but you don't have to toss the entire thing out. Okay. All right. So we'll kind of keep in mind, why we are doing this. But is it clear to everyone that the first line that I highlight is the same as the second line? Or the first line implies the second line. I'm not adding any additional information, and yet the second line does not conflict or contradict the first line either. So it's okay. Okay, it seems like it's just something redundant. We don't have to do it, but for whatever reason, text wants to do it, we'll just go ahead and do it. Okay. The other thing that you also want to kind of pay attention to is the new thing that I added is relating x to something that doesn't change within this block of code. Because within the block of code here, from line 1 to line 2, you can see that x and y are the only 2 variables that are getting changed. N and k are just symbols that are referring to some kind of value, but they never got changed within this block of code. Okay, so what I'm trying to do here is to relate the variables to things that do not get changed as much as I can. Okay, I'm just trying to push it as far as I can. Okay, the reason why I'm doing this will be clear, in I think about 5 minutes or so. Pre-2 is post-1. That part is pretty easy because lines 1 and 2 are sequential. Okay, they're just line 2 is following line 2 is following line 1, and that's why the post condition of line 1 is the same as the precondition of line 2. Okay, so that part is okay, pretty easy. And when you're doing your homework assignment, you can kind of do the same thing here. When you think the same type of reasoning is applicable, just copy and paste and then change the details to reflect the new line. So in this case, line 2 has n and on the right-hand side, and the left-hand side is y, variable y. So now we have to say f of y has no inverse for the same reason, because n does not refer to y, and as a result, there's no way for me to reverse the operation. So once again, we have to apply the forget operation. And it looks about the same here. Okay, post 2 is based on pre-2. Okay, we have to forget everything that we knew about which variable in this case. Y. Okay, because y is the variable getting changed. So potentially anything that we knew about y is no longer true after this point. And then we can say, oh, but from now on, y has the same value as n, because that's what the assignment statement is going to do. And then we'll do the same thing here. We'll expand what is pre-y. Pre-y is post-1, and we'll copy and paste this entire thing, including the part that seems to be redundant, into the forget operation. And we'll keep y equals n to be outside of the forget operation. So there's nothing new here, right? I mean, this is exactly what we did earlier with line 1. Okay. Are there any questions? I'm also, using this opportunity to let you guys, kind of write it down. Any questions?
If you had multiple assignment statements, would you use what you put in pre-2?
If I
Does that
had,
make sense? Like if you had, would you put the same thing for if you had an assignment statement for line 3 as pre-3 and then?
you mean having pre-3 equals post-2 because they are sequential?
Yes.
Yep. As long as they're truly sequential, because if you have in a conditional statement, line 1 and line 2 may not be sequential because there's one chance that you may not go to line 2. Okay, but in this case, because these two statements are right next to each other, and therefore they are sequential. Okay. So in your homework assignment, you will have you have 3 statements that are truly sequential. Because inside the then block, you have 3 assignment statements, so those 3 are truly sequential. So you can use the rationale of because line blah and blah are sequential, you can use it twice to connect one line to the next one, and then that one to the last one. Okay, so now we'll go ahead and perform the actual forget operation. We look at what pre-2 looks like, and we say, okay, does it refer to y? Oh yeah. Okay, it does have components referring to y. So this time we do have something to do in order to perform the forget operation. Any questions? Anything I can clarify? Okay, go ahead.
Last time, I don't know if the other time you did post 1 or not. Do you always have to do post 1? Because almost always the same as pre-2.
Post 1.
Post 1 and pre-2. Like
You do have to
time
explain it, because otherwise, why do you start with how do you know pre-2 if you don't link pre-2 to post 1? Okay, and it's not always the case also. Okay, because it's not always the case that the line number implies 2 statements are sequential. Okay. All right. So right here, we have something to do, because anything that mentions y, we don't want to keep around. The first one is y equals k. So we have to toss this one away. And the second one, x equals y, we also have to toss it away because it also mentions y. So now we have only x equals k left from the forget operation. But on top of that, we also know y and n are the same because of the assignment statement on line 2 itself. Are we doing okay so far? And that's the conclusion, okay, for this particular example. Now, what you want to think about is, what if I did not perform this extra step that seems to be just adding something that is redundant? If I did not perform that step, then you would have lost x equals k in the process. Okay? Which is okay. I mean, the post condition is still the post condition, but it's not as informed anymore. And this is better because now it is more informed. It's actually telling you more about the conditions of the variables after line 2. Are we doing okay so far with this concept?
Could you have simplified that line one more time and just gone straight to x equals k in post 1 below the highlight or the highlighted line? Because if you know that y equals k and x equals y, therefore x equals k, could you have just gone down another line and just left it as x equals k for post 1?
Well, then you'll be losing a lot of useful information.
Okay.
If you perform this step here, it is actually not equivalent. In other words, this line and this line are not equivalent.
Okay.
One does imply the other one, but not the other way around.
Okay.
Now we want them to be equivalent.
Okay.
Because what you're saying is this line actually implies this line. Okay.
Okay.
All this gibberish, is actually more confining because we are adding the extra constraint that x and y must be the same.
Okay.
This line does not say anything about y, so they
Okay.
do not have to be the same.
Okay.
Okay. So we don't want to perform that step. Okay. If anything, we are just adding more redundant stuff. Okay. So that the forget operation later on will still have something useful that is retained. In this case, we are retaining x equals k. We would have lost that information if I did not, add that part earlier.
I actually left that there. Okay.
Okay.
Sure.
So are there any questions? Any questions about the rationale of why we are doing this? Yep.
So, should in every single case, should you always expand it out to get as much information as possible so that in the next step, whether or not you know it's going to do a forget rule or not, you'll have the information available?
Ideally speaking, yes. But most of the time, if you can look at a block of code and you can identify things that do not get changed, as long as you can establish variables to things that do not get changed, you'll be good. Okay? All right. Okay, so now getting back to why we need something that seems to be pretty obvious. Okay, why do we have to state that pre2 and post1 are the same because these two lines are sequential? Okay, I will just give you one simple example here, and I will say if x is less than y, then x gets y. Okay, and if this is a clear example of why we have to say that, because in this particular example, pre2 is post1, it does not make any sense. Okay, because those two lines are actually not sequential. Okay, they are representing different parts of a conditional statement, but they are not necessarily sequential. Yes, sometimes line 2 may follow line 1, but not all the time. Okay, so in this case, I cannot say pre2 equals post1 because blah blah blah, because there's really no single post1 to talk about. It can be from line 1, I can go straight to post3, or I can go to line 2. So so in this case, I cannot say anything about these two lines are sequential. Therefore, the post condition of one is the precondition of the other one. Are there any questions about the homework? Pre-post condition thing? No. Okay. If there are no questions, I'm going to save this file and upload it to Moodle, just in case someone could not copy it in time. I will still have a copy on Moodle. So I'll just call this, pre-post. What should I name this? Oh, if I just call that, I know what to do. 2013-10-03 prepost.txt. So this way it's clear what date I actually wrote this note and what it is for. Okay. And then we'll go back to class website, turn on editing, start up the file manager, go to my temp folder to find the file that I just saved, which is right here. And then go to pre-post conditions, drag and drop the file, now it's uploaded. Okay. Any other questions? No other questions? Okay. If there are no other questions, we'll get started with the practice exam. Yep.
The empty else statement, you just do the one before, right? Like,
say again?
let's say if empty else statement, how does that work again? You just
the empty else statement, or any empty statement, right? Okay, an empty statement is, as the name implies, an empty statement. So what does it do?
It goes on to what it's before, right?
Absolutely nothing. An empty statement doesn't do a single thing. Okay? It's a null operation. It doesn't do anything. It's a no op. Doesn't do anything. In other words, it does not change any variables. Okay? So whatever is an empty line, is a statement, but it doesn't do a single thing. As a result, how do you relate the precondition to the post condition of that line?
Same.
Exactly. So you just explain post whatever line equals pre whatever line, because the line is an empty statement. It doesn't do anything, doesn't modify any variables. It is only there for one single reason. It is only there for the purpose of clarity. Because if I do not put that line in, then most people will forget, hey, there's actually an else branch. Yep.
One more. If there's three statements like back to back, would you always do it and there's a pre-1? Like let's say there's pre-1 and there's like 3, 4, and 5.
Mm-hmm.
On for the third statement, for E3, would you do pre-1 and then something else? And same with 4 and 5. Would you always do pre-1 and something, or the one before?
It's always the one before, because the one before can change a lot of things from the precondition prior to the previous line. So you can only go from line 1 to line 2. You know, the post condition of line 1 becomes the precondition of line 2, and then the post condition of line 2 becomes the precondition of line 3.
Yes, no, but I meant just the preconditions of 3, 4, and 5.
The precondition of 3, 4, and 5.
Okay.
Are you referring to the homework?
Yeah.
Okay, the first question or the second?
First one.
The first one? And the question is?
The pre of first one is x equals n and y equals m. So for the pre of 2, 3, and 4, would you do pre 1 and t equals x, or x equals y and y equals t, or would 3 just be pre 2 and y x equals y?
Oh, I see. So like what you're saying is like for line 3 is it the precondition of 1 and then also what you get for line 2.
Yeah.
It only depends on the line before it,
Okay.
immediately before it.
Okay.
Because anything that's before that can be affected by the line right before that. Okay. So we can only go, you know, step by step. There's no way to jump steps, and the precondition of one line is only dependent on the line before, if there's one line that is sequentially before that line. Alrighty. So I think that's for the homework assignment. And since I think everybody is here now, I'm going to pass the roll sheet. I'm just going to pass the roll sheet. If anyone sees, you know, like 2 bars, you know, next to your name, that means you have missed at least 2 classes. The 2 classes that I can count, and 2 classes is already considered excessive absence in this class. So that means, you know, you need to kind of explain to me why there are 2 absences. 2 people have turned it in already. Nice. Well, remember, you can turn it in and not have it completely finished, and then finish it some more, and then turn it in again. Okay, so that's, you know, Moodle just keeps the last one that you upload, but it does allow you to upload before the due date. All right. So now we'll go ahead and start with exam 1 practice question. It is actually under topic 2, which implies exam 1 is not going to include pre-post condition stuff. I think I kind of mentioned that before. No? No. But I don't see any sigh of relief. There's no.
I think you mentioned something
Well,
about it, yeah.
well, but I'm just going to put it into the second exam, right? I mean, it's not like I'm you know, not going to ask any questions at all about pre and post condition. It's just going to be moved on to the next exam. All right. So this is a spreadsheet. You know, if you open the file, it is just a spreadsheet, and it has, you know, samples of questions that I will ask. In fact, you know, what you want to do is look at this as an indicator of what kind of question I might ask, but not exactly, you know, the same question or same kind of question that I might ask. In fact, I'm giving you all too many answers here, so I'll just go ahead and remove the answers.
Well, you're fine.
Well, otherwise, you know, there won't be any fun doing it. So we'll go ahead and erase everything that we see here, and also this one. All right, so now we have erased everything, and we'll go ahead and, oh, in fact, I'll put back one of the error that I put into here. Oh, it's already here. That's good. All right, so we'll go ahead and start with the first question. You know, this is the first question. Before I get started, I do want to tell you, you know, the nature of exam 1. 1, it is individual, so no team group effort in the exam. Okay. All right. And you can think of teams of 1, okay? You know, each team only has 1 member. So yes, it is a team effort. Very good. Team of 1. If the army can say army of 1, you know, we can say team of 1 as well. So the second thing is it is open book, open notes, okay? You can bring anything, any material that you think will help you, as long as it is on paper and it is done prior to the test. Okay? I have to say prior to the test because I don't want someone to write some notes on a piece of paper and slide it to the next person and say, but I'm just sharing notes. Okay, so I think of all of these things.
Did it happen to you?
Hmm?
Did it happen?
No, but I can see it happening. Someone can argue and say, but you said anything on paper. Well, anything on paper that is prepared prior to the test. Okay, my suggestion is to read all the notes, do all the make sure you understand all the homework assignments or the solution to all the homework assignments. If necessary, watch certain parts of the lectures, okay, on YouTube. If there's one lecture that I kind of messed up the recording, but fortunately that one was kind of redundant, because we talked about all the stuff already. You can also watch the one from the morning class, okay, the AM class, because we're covering about the same kind of material. So if my explanation for the PM class, for this class, is not very clear, and you say, well, maybe there's a better way to explain that, you can also watch the one from the morning class. It is also on YouTube. You can bring books if you want to. If you find algorithm books that you think will be helpful, bring it in. But my personal suggestion is once you study the material, once you study your homework assignments, once you look at all the sample programs that I do in class, prepare your own concise notes for the exam. Okay, it should be just about 2 or 3 pages long. Okay, so this way, one, by writing that note, preparing that 3 sheets of paper, you are already studying. Okay, that's a part of the study. And 2, you will know where to find what, right? Because because you wrote it, right? The second page, the middle part, is about loops. Okay, so and 3, it is not a big pile of paper. It makes it very easy to locate the parts that you need. Yep.
Could it be printed?
Sorry?
Could it be printed?
Yes, it can be printed, as long as it's on paper. Okay, so that means no electronic devices during the test. Okay, no cell phone, no laptop computers, tablets, and so on and so forth. I don't think the calculations involved will necessitate calculators because it's just basic arithmetic stuff, addition, subtraction, multiplication, and occasionally division involving integers. Okay. So I don't think it will be necessary to bring a calculator in, but if you think a calculator may be helpful, you can bring a very simple one, like the ones that you buy at the Dollar Tree. That'll be fine. So for people who say, but my cell phone is my only calculator, well, I can give you $1 so you can go to the Dollar Tree and pick up a calculator. Not a problem. In fact, I would probably just go to the Dollar Tree, buy a whole bunch, so in case anyone needs a calculator during the test, I have loaners. Hey, you can buy a scientific calculator at the Dollar Tree for $1. It can do sine, cosine, tangent, exponent, and log, and all that stuff for $1. All right. So now that we have all that stuff taken care of, are there any other questions about the exam, the procedure, what you can do, what you cannot do during the exam, that sort of thing? Yep.
Is it handwritten? Do we have to handwrite the work and everything?
Yes, it is all handwritten, so you might want to bring pencils, extra pencils, erasers, and maybe extra sheets of paper just in case you need it. I will give you enough room to write your answer, but some people like to write it on a separate piece of paper, so bring your own piece of paper if you think you might need one. Yep.
So when exactly is the exam?
When?
Yeah.
Good question. I put it into Moodle just recently. So if you look at the 10th, it is our exam 1. All right. So any other questions? So we have 1 week from today to the exam, which also means if you study over the weekend and you find out, hey, I'm not quite sure, how to deal with this, bring those questions on Tuesday so we have one more chance to talk about it before the exam. And that's exactly why I talk about the practice exam 1 week before, or 2 classes before, 2 classes before the actual exam, 1 class before. Okay, so this is a typical question. This is not the same kind of question that I asked from years ago. This is not going to take as long, so that's why I'm going to ask more questions. Each question doesn't take as long. Trace the code until the algorithm exits or end is updated 2 more times, whichever occurs earlier. Okay, If you continue to trace the entire thing, I'm not going to take any points off, but you'll be wasting time. Okay, so you want to do it just when n is updated 2 more times, then you can stop. All right, so let's take a look at this algorithm here, and take a look at the trace. The trace is right here is a partial trace. That means I'm already done. I have already traced the algorithm up to this point. We are not starting from pre. We are not starting from line 1. I am in somewhere into the trace already. So we are starting somewhere inside the algorithm, not from the very beginning. So keep that in mind. Okay, because otherwise some people will make the assumption and say, oh, pre, okay, we'll start from the beginning. Nope, we're starting from line 2 in this case. This 1 here means n has a value of 1 after line 2 executes. So we are done with line 2 already, and n ends up with a value of 1. That is consistent with the traces that you have done up to this point. Same convention. All right, so the next line is where? Where do I continue execution from here? We continue onto line 4, exactly, because we are out of the conditional statement. Because in the conditional statement, you take one of the 2 branches. When you're done with one branch, you exit the entire conditional statement. There's no going back for conditional statements. On line 4, it is a pre-checking loop, so you do have to indicate the condition here. Okay, just copy the condition from the while statement itself, and then you have to indicate whether it is true or not. N is less than 8 is true. Okay, so you just say true here, and then where do we go?
Line 5.
We go to line 5. And this is another example, getting back to the pre and post condition thing. This is another example that you cannot say pre 5 equals post 4, because line 4 has 2 ways to proceed. It can go all the way to post in this case, or it can proceed to line 5. So that's why there's no such thing as post 4, because there are 2 ways to proceed. Okay, so we get to line 5. What does line 5 do? It's doubling the value of n, so n goes from 1 to 2, and then where do we go? We go back to line 4. Okay, we go back to line 4 because line 5 is the last thing that we have to do inside the loop, and after you do the very last operation inside the loop, you have to go back to the beginning to reevaluate the condition to see whether it's time to get out. Okay, so now we reevaluate the condition. It is still true because 2 is less than 8. Then we continue onto line 5 again. We double the value of n. It becomes 4. And we're done. Okay? The algorithm is not done. The trace is not done. But as far as the answer is concerned for this particular question, we are done because we have just performed 2 additional updates to the value of n. Any questions?
So, when 1 turns to 2,
That's one update.
Before it goes to the while, end it only goes through it once.
Before it goes,
End it, there is no loop in that, right? 'Cause
a conditional statement is not a loop.
Okay,
Therefore,
a
it does
while
not
is.
go back to the beginning. A while is. Yep. Sounds like a little bit of studying there. Pictures, All right. So this is good. A pretest is actually helpful, because now we know, what we need to study. Or not. All right. This is the second question. Now, you don't make assumptions about the instruction. Don't look at the question, the format of the question and say, oh, I know what I need to do, okay? Because they may be slightly different. The second question says, the instruction says, start with finishing the tracing of line 11, which means line 11, which is actually line 1 here. It's my bad here.
Magic.
Yep, I caught it first. So start with finishing the tracing of line 1, then trace the algorithm until the algorithm exits or m is updated 3 more times this time, whichever occurs earlier. Okay, so this is what we need to do is line 1 is not quite done yet. Why is it not done? I mean, we have n, we got n, this is line 1, what is missing? What is the condition, right? Because line 1 is the conditional part of a or it's the part that states the condition of a loop. So we have to evaluate the condition and say, is it true or is it false? Because otherwise you cannot know whether it's time to exit the entire thing or get to the next line. All right, so we'll do n is less than m it is true because n is 8, 8 is less than m, which is 20, is true. Okay, so now we continue execution onto line 2. And line 2 is the beginning of a conditional statement. So we have another condition to evaluate. N is greater than 8 is, it is false. Okay, it is false because 8 is not greater than 8. Okay, now where do we go?
Step
5.
We go to line 5 because the condition is false. We have to go to the else branch, not the then branch. Okay, so when we get to line 5, we are going to do something to m. M is going to be decreased by 1 from 20 to 19. And then where do we go? We go to line 7 because line 7 is the statement following line 6, which is the end of the conditional statement. So getting back to the pre and post condition thing, pre-7 is post-6 in this case because line 7 as an assignment statement is sequential to the conditional statement, which is starting on line 2 and ending on line 6. Okay, I'm just using these extra opportunities to explain, when to use the sequential thing to explain why you have the precondition from the post condition of something that is before. Okay. All right, so we get to line 7. Line 7 is just subtracting 1 more from m. So we get to 18. And then where do we go? We go back to line 1. Okay, we go back to line 1. Now, as a general rule, if you're going back to an earlier line, that line itself should not say if, it should not say else, it should only be a while. Or not even a repeat, because we don't even trace lines with the word repeat on it. Okay, so that's a general rule. If you're going back to a line and the line says if or else, something is not right. All right, so we are getting back to line 1. We reevaluate n is less than m, and it is still true because n is 8, m is 18, and 8 is less than 18. Okay, so the condition is still true. We go to line 2 again. Since we did not make any changes to n is still less than or equal to 8. Okay, so we are, that condition is false. And then we go to line 5. Line 5 is going to decrement m by 1. So we go from 18 to 17. And this is the third time we update the variable m after the line that we started off with. So that's the answer. As far as the answer is concerned, we are done. The algorithm itself is not. Yep.
Just to make sure, you would go to 7 if 2 had been true, then you'd go to 3, and then you would go to 7, and then you go back to 1. Okay.
That is correct. Because whether the condition on line 2 is true or not can only help you select, am I going to line 3 or am I going to line 5? When either branch is done, we still have to continue on to whatever statement is after the conditional statement. In this case, it is line 7. Okay, that's a good question. All right, so do we have any questions about this particular one? And you can see the instruction is slightly different from the first one. And sometimes that is really, really important. Okay, the next one I think is kind of fun. And of course, the version in the exam itself would be even more fun. Okay, read the instruction first. Find a value of x so that z ends up with a value of 3. If it is impossible, which means maybe it would be impossible sometimes, explain why. If it is possible, trace the algorithm from pre to post, start with specifying the value of x in the precondition. In other words, I left that space open so that you can put in some value for x as a precondition, and then you trace the algorithm to confirm that you can actually get to that particular value, that I want in z. Okay, is the instruction itself understood? Yes? Okay, go ahead.
Do we need the value for it?
Do we need the value for?
An assumption.
That's what you're trying to figure out. Okay, so we want to figure out what value of x can get z to end up with a value of 3. Okay, Now, first question, as a lazy person, the first question that I ask is it possible that z has a value of 3 to begin with, and I don't have to do anything? I can just say, assume z has a value of 0, of 3. In fact, I can make this question trickier and say, hey, let's take this one out and make it a 3. Would that mean that you don't have to say anything, and then you just say, it's already done, I don't have to do anything?
Yeah.
No. I mean, you guys should know me by now and say, no, something is wrong here. Tech would never, give away something that easy. Okay, now the question says find the value of x, so z ends up with a value of 3 after the algorithm is done. Okay, so if x starts with a value of 3, does it guarantee that it will still be 3 when the algorithm is done? Look at every single branch of this algorithm. Every single branch is going to assign something to z, right? There's not a single branch here that doesn't touch z. So that means depending on the value of x, something will happen to z. We just want to control what is happening to z so that z ends up with a value of 3. So even if in the precondition I give you a value of 3, you still have to figure out what value of x will end up with a value, will make the algorithm execute so that z ends up with a value of 3. Is that okay so far? That's a good question. Some previous student, in fact, in one of my first semesters here, and he's a really good student of mine too. He said, I have a talent, a knack to ask questions in a very confusing way, at least to him. And back then, I only used multiple choice questions in all of my exams. And he said, my question, the way I asked the question, always point to the wrong answer. So I just gave up on multiple choice questions, and now it's all open-ended. All right, so let's take a look and say, okay, now we have several branches to consider. We have all of these branches that are possible. This is a multi-branch conditional statement. Which one do you think will make z equal to 3 when the algorithm is all done? It's pretty clear. I mean, line 8, right? So line 8 is what we are shooting for. Okay, we want to execute line 8 here. Great. Now that we know what our objective is, now we have to figure out what value of x will get us there. Okay, it looks pretty easy, but it's not. Okay, so we'll go ahead and say, oh, I know, it's easy. Anything that's greater than 3, I'll pick 4. Would 4 land me? Would 4 let me land on line 8?
No.
No. Which line would it land me instead?
3.
It will land me on line 4 because the condition of line 3 is going to be true first, and we evaluate the conditions from top to bottom. When we find one that is true, we execute that branch, and we're done. We don't even bother to look any further. Okay? Because you have to remember the picture of a multi-branch conditional statement. Okay? We have one branch over here. If it is false, we go to the second branch. If that is false, we go to the third branch. But if any branch has a true, we execute that branch, and then we exit the entire conditional statement. Okay? So you got to remember the picture. All right. So that means it's not really quite as simple as we think it is, because in order for us to execute line 8, this condition has to be true. That part is definite. But this also has to be false. This has to be false. This also has to be false, which means x cannot be 0, cannot be 4, and it also cannot be less than 4. It has to be greater than or equal to 4. Okay, but since I already said it is not equal to 4, if I add on top of that, it cannot be greater than or equal to 4, it means it has to be greater than 4. Okay, and that's why 4.1 is going to do it, right? I didn't say it has to be an integer, so you can say 4.1 or 4.0000001. You know, you guys can play with that. As long as I can see it's more than 4, then it'll be okay. And no limit, okay? You know, please do not do something like this. I don't have a dry bar marker. Okay, I can probably approximate that. You know what? I can do it here. So I'll just use a word processor just to show you what you can do with LibreOffice Writer. Don't give me answers like this. 4 plus x, where insert object formula. And then inside the formula, I would use, let's see here. Yep. I'm looking for limit. No. Where are my limits? Oh, okay, I guess I can do this like this. Okay, limit, but I need to specify the bottom part. There's one way I can specify the bottom. Okay, brackets. I haven't done this for a long time. There we go. So we have to pick this guy here. Okay. So the limit up here is, let's see, nope, nothing up there. Limit itself is the one on top. And then the subscript part is going to be x goes to infinity. I think most of you know what I'm talking about here. But now I'm obsessed with getting this done. Where's infinity? So, under symbols. Yep, those are operators.
Does it support using a backslash typing infinity? Or
Oh, I guess we'll like that.
no?
Nope. Okay. I'm gonna give up for now because it's taking too much time. Okay. But I'm just saying that don't give me something that is that is kind of, maybe it will do it, maybe it won't do it. Okay? Because if you say 4 plus x, 4 plus 1 over x, where x is approaches infinity, then it becomes a good question, right? Then I have to take your answer to a math professor and say, okay, will it ever be considered 4? No, it will never be considered 4. Okay, you get your points. Right? Okay, so but 4.1 works well. Okay,
So you're actually looking for a value in this case because you did ask find the value.
Yes, yeah, exactly. You can say 400 if you want to, and anything greater than 4 would work in this case. All right, so now you have to trace the algorithm because that's also a part of your answer. If it is possible to trace the algorithm from pre to post, from beginning to end, starting with specifying the value of x in the precondition. So I just did that. So now we go to line 1, we say x equals to 0 is false. Then where do we go? Line 3, yep, because we have to evaluate the next condition. X equals 4 is false as well. Then we go to line 5, and then we say x equals,
X is less than 4.
well, x is less than 4 is false. Then we move on to line 7. X is greater than 3 is true. We execute line 8. Z now ends up with a value of 3, and then we get to post. We are done. Any questions? If I were to ask you, is there a dead branch here? In other words, is there a particular value that cannot get into Z? Do you think there's one? It'll be,
Line 10.
yep, it'll be line 10. So 5 is not a possible value. Okay, there's no way to get 5 into Z because line 10 can never execute. Now, you have to think about how do we get to line 10? In order to get to line 10, all of these conditions have to be false. And there's no way to make all of these conditions false. At least one will be true. Okay? Yep.
What about imaginary ones?
Imaginary numbers. You cannot compare imaginary numbers, can you? The comparison operator is undefined for imaginary numbers. Good one. Okay. The next question is the dead branch always going to be the else? It's going to be the last one. Nope. The quickest and easiest way to create a dead branch is to turn this into false. Right? When can false become true? Never. Right? So that means in this case, line 2 is automatically a dead branch. There's no way that I can execute line 2 in this case. Oh, but doesn't that mean everything else is going to be dead as well? No. The next branch is entirely possible. Okay, so you cannot make any assumptions, about, oh, the dead branch is always going to be the last one, because any one of these can be a dead branch. Is it possible that there can only be up to one dead branch? No, you can have all of these being dead branches. Actually, I take it back. With an else, you have at least one live branch. They cannot all be dead. Without the else, they can all be dead. But with an else, like the last one on line 9, at least one has to be live. All right. I'm just telling you, do not make assumptions in the test, okay? Make sure that you apply your analysis to every single one as much as you can. Okay, any other questions about this particular one? No questions? All right. I'm saving all this too, so I can upload it later. The next one is very interesting. Okay, in fact, let me erase this line first. Delete and select the row. There we go. Okay, the next one is this question here. And I'll just read the instruction first. Continue the trace until the algorithm exits, or you can conclude the algorithm can never exit. If the algorithm does not exit, explain why. In other words, if it's stuck in an infinite loop, then you say, oh, okay, there's no way we can finish the algorithm because it's stuck in an infinite loop. Okay. And if you look at the trace, the partial trace here, it says we are on line 6 already. After line 6 executes, we have a value of 4 in variable I. Okay? So as far as you're concerned, you can just continue the trace and say, okay, the next line after line 6 is, yep, we get back to line 2 because line 6 is the very last operation, the last statement inside a while. So we have to go back to the beginning of the while loop and then perform, we check the condition again to see whether we have another iteration to perform. Okay, so we'll do this part first, and then I'll tell you which part I messed up. Okay, because there is one little mess up here, but most people cannot spot it. Okay, well, I'll tell you what it is. I know some people are now taking that as a challenge. It's like, okay, I need to figure it out before tech gets to the end of this particular example. Okay, so we get back into line 2, and line 2 evaluates the condition. I is less than 6 is true, because 4 is less than 6, right? Then we continue on to line 3. Line 3 is evaluating I is different from 5. Is that true?
Yes.
Absolutely. So what do we do?
Add 1.
So we go to line 4 to add 1 to I becomes 5. And then what do? We get out of the conditional statement, continue with whatever is after the conditional statement, which is line 6. So on line 6, we add 1 more to I goes from 5 to 6. And then we go back to the beginning of the loop, which is on line 2. And it reevaluates the condition, except this time the answer is different because I is already 6, 6 is less than 6 is false. And then where do we go? Post is correct. Okay, because this is the only thing we have to do in the then branch of the outer conditional statement. When we are done with that branch, we exit the entire conditional statement. In this case, there's nothing else following it, and that's why we get to post. Are there any questions about this code here? Did I mention that I messed up here? Okay, what is the mess up?
Well, maybe I'm just reading it wrong, but I don't really think it's possible for line 6 to have 4.
That is absolutely true. Okay, so that's where I messed up. Well, not in the current state, okay? I can actually do one little thing to save myself and say, yeah, it is possible, okay? But let me explain why it is not possible the way the code is structured at this point, okay? Okay, so let's backtrack, okay? So this time we're working with pre and post condition, basically. Okay, so let's go back to this line of the trace first, okay? We are saying that after line 6 executes, we have a value of 4 in I. Okay, well, let's go to line 6. Okay, so knowing after line 6 we have a value of 4 in variable I, what is the value of I before line 6?
3.
It's going to be 3, right? Okay. So that means right after I exit from the conditional statement, I has a value of 3. Okay, well, that by itself is okay. That's entirely possible. But what does that mean? What does that tell you about I before the conditional statement? If after the conditional statement execute, I has a value of 3, what is it telling you about pre-3, the precondition of line 3? Think about it. I hate it when I don't have a dry board marker in the classroom. We have these neon, color things that are not erasable. Maybe they are. No, it doesn't say. It's a highlighter. I don't want to use it on the whiteboard. I'll be screamed at the next day. Can I borrow it?
It's water marker.
Oh, it won't work on the dry board.
Yeah.
Unless they use a pressure washer the next day. That would not be good either. Okay. So I'll just kind of point it out here.
So wouldn't that be that you couldn't even get there because it wouldn't be greater than 3? Like you wouldn't even get if I was
Right.
already 3, then yeah, you couldn't even get into that.
Exactly. Because but I can at least trace my way back to here too, because in order for I to have a value of 3 at this point, it must have a value of 2 at this point, because it must have gone through this part.
Yeah.
Okay, the only way it doesn't go through this part is I had a value of 5, but we already know I had
Or
a value of 3
Yeah.
after the increment. So before the increment, it must have a value of 2, which is consistent with I is different from 5. And then before this one, we get to here, which is okay. I mean, I is 2 at that point.
It's less
I
than
is
6.
2 is less than 6. That's good.
But 2's
But
not
before
greater
that
than
point,
3.
It won't even exist.
it wouldn't even we should not even be
In
able
that
to get to
range.
line 2.
Yeah.
Okay, because if I had a value of 2, which is the minimum that it can
You
get
wouldn't even gone
according
into the while loop.
exactly. So just by backtracking the program, I can now say, tech messed up somewhere, because I cannot possibly have a value of 4 when we get to line 6. Okay, so this is the kind of analysis that will be helpful when you're debugging a program. Okay,
So if we
because
were
it's
to
the
see something
same
like
process.
That on a test though, could we just say TAC is wrong, this doesn't work?
I think if you can identify that, you deserve the points.
Alright.
But you have to
That's
tell
good.
me where I made the mistake. Okay, if you think I made the mistake, you have to say where the mistake was, and therefore this question is not valid. Now, let me just add one more line to this program, and it just turns everything around. I become, infallible again. Okay? It sounds so preachy. All I have to do is to add a label here. Label 1, wait, where's my case? Label 1. In most programming languages, they have, 2 things that can save any programmer from anything. It is called a label and a goto. Okay, so let's just say that you have a big, huge algorithm, okay? You can stick a label anywhere you want, and you can use a goto statement anywhere you want. When the program gets to the goto statement, which is just a statement, it always continues execution at the label that is named, that is naming. So in this case, I can get to this label L1 from wherever in the program, as long as the statement says go to L1. Okay? So now everything is possible again, because I just bypassed line 1, line 2, all the way to line 6. Are you guys seeing what is happening when I have a go to? Okay, because it's a wormhole. It can go from anywhere to anywhere else in the universe. In fact, it can look back to itself. You can have a label, and then the next line just say, go back to this label. It becomes the tightest infinite loop ever. Okay, that is why the word "go to" is the G word in programming. It's a taboo. We don't want to say that word. We just say the G word or GOTO. We never say "go to." Okay. Does anyone watch Harry Potter? Okay, the V word. They don't want to mention the name, right? I mean, it's like, oh, we don't want to mention that name. It's so scary. The same thing here, the G word. Yep.
So is there any way to exit a go to?
Any way to exit what?
Exit out of the go to state.
Oh, it will exit just fine. Yeah, it will exit. In fact, let's see. We'll keep incrementing, and then we just exited the loop here, right? I mean, the algorithm actually came to an end. The question was, how do we get to line 6 and have a value of 4 in it? And it's not possible under normal circumstances. But if I put labels into the code and I say, but I can branch to here from anywhere, then it becomes suddenly possible. Okay? And that is why you don't want to use go-tos or labels in a program, because it completely messes up any type of reasoning within that code. Because you cannot apply all the reasonings that we apply normally to analyze a program. Okay? Are there any questions? Yep. Oh, thank you.
They call it spaghetti code, right?
They call it spaghetti code, named after a bowl of cooked spaghetti, being kind of messy, and it's really hard to see which spaghetti is leading where in the bowl. Yeah, but it has to be cooked. Spaghetti before cooking is fairly straightforward. They're all sequences, right? You don't even have branches. But they're all parallel sequences. All right. So this is a really, really good example to show not only how to analyze a program and say, hey, something is wrong here. I cannot be 4, on line 6. But also a good illustration of why go-tos and labels are really, really bad ideas, because it just messes up this program. Because by the time you get to line 6, you cannot make any assumptions whatsoever about the conditions, because you can get there from anywhere. Okay, just bad ideas. Do not use go-tos. Period.
Why do we have them in the first place?
We had those in the first place because whoever invented C and C++, those two guys, okay, I think they're Carnegie and Ritchie. Let me just look it up. Okay, C language inventor. Okay, there we go. Yep, so we got Dennis Ritchie and Brian Carnegie. Okay, that's it. And one of them just recently died. In fact, I think he died like a week or so before Steve Jobs died. Okay, and nobody noticed anything about one of the most important person in programming languages passing away. But when Steve Jobs passed away, it's like, oh no, Steve Jobs just passed away. What's going to happen to all the iOS products? Who cares? Right? Because the point is, without these two guys, the programming C language would not have existed. They actually invented the programming language C and C++. Not C++, but just plain C. But C++ is based on C. Okay, they borrowed maybe 90% of C and just add something to it. But then you say, but Apple is weird. They don't use C++. Okay, they use Objective-C. Well, guess what? Objective-C is also based on C. So without these two guys, Objective-C would not have existed either. Okay? In fact, iOS would not have existed because iOS is based on Linux. Well, no, excuse me. Take it back. iOS is based on BSD, which is Unix. Okay? These two guys wrote the original Unix operating system. And they were writing the entire operating system using assembly language, really small building blocks. Think of building a house using grains of sand. okay, and tweezers and loops and stuff like that, okay? So after a while, these two guys just got bored, okay? Because even though they can do it, it is not a very exciting kind of thing to do, okay? So they invented a macro language to basically say, okay, if I write this little line of code here, it should expand to this chunk of assembly code to save themselves a lot of time. And that was the precursor of what we know as the C programming language. Okay, so that is the significance of these two guys. Now, why would they put gotos into the programming language? I can give you one quick answer. Because these guys knew what they were doing. Okay, they knew what they were doing. They were writing a programming language basically for themselves. It was not intended to become a universal programming language, including first year programming computer science students. Okay, so is that okay? Does that explain why gotos and labels are there? Just don't use them. Okay, in fact, if anyone is programming in C and C++, I want you to do something like this. I just remember I don't have a dry bar marker. But what you can do if you want to avoid the temptation to use gotos in your program, just say this. Just define goto, the word itself, to some gibberish. That's all you need to do. Because what happens is, this is called a macro definition in C. It basically replaces goto, G-O-T-O, with the gibberish that is defined to. So your program would not even compile, okay, if you use the word goto.
Unless you just accidentally typed in the gibberish.
Yes, yeah. Some people can do that, but I cannot. All right. So a little bit of background in C, in the C programming language. Okay. I think we do have one more question. Good to go, which is this one here. No, that's not the question. It is a modification of this code here. Okay. So we take this code here, and then we turn it into something that looks like this. And I can ask you exactly the same question. But in this case, it is possible to get to line 6 and have a value of 4 in I. Okay? But the behavior of this program is different. What is this program going to do eventually? It has a loop inside the loop. Now, we know the inside loop is going to exit. Not a problem. We already got that part, right?
But it's going to run forever.
It's going to run forever because when the inner loop exits, we'll be on line 2, and I would have value of 6 by that point because we just did that earlier, right?
And there's no inverse.
So what it will do is when this condition is false, it will. So that means this entire statement is done. This entire statement is the body of the outer loop. Okay. So as far as the outer loop is concerned, it has to go for another iteration, possibly. So now we'll go back to line 1, and then line 1 will say, oh, okay, I'm going to check whether I is greater than 0. I is 6 at that point. 6 is greater than 0. It's true. Okay, good. Let's go to line 2 again. Line 2 says, I is not less than 6. I'm not going to do anything. Exits the inner loop. Get back to the outer loop. Outer loop says, we're not done yet. Yes, we are. No. Yes. No. Yes. No. Yes. And it would just keep going like that. Then you have to say it's an infinite loop. Is that okay? Or more confused? Nope. Okay, very good. So these 4 questions represent the kind of question that I can ask you. The actual questions will be based on this type of question. I give you the pseudocode. I give you a starting point, which may or may not be the precondition. And I will ask you to do a simple trace. It's not going to be very long. I'm not going to give you a trace where it will span multiple pages. I cannot give you an upper bound right now, but it will just be about the same as what we are talking about here. There'll be about 8 questions or so, like this. And that will be your exam 1. Yep.
So will it be entirely tracing?
Yep.
Okay.
Yep. It will be entirely tracing except for the one where I want a particular value in a variable, because in that one you also have to analyze the code a little bit, and then you have to trace it. Any other questions about this exam? No other questions? All right. Well, we have 10 more minutes to go, so it's time to get started with a new section, a new topic. So this class is still a little bit ahead of the other class, but they're catching up. So that's good. So now we move on to topic 5. No, actually topic 6. Topic 5 should be hidden because it actually doesn't have any content in it. Topic 6 does. I should move it out of the way altogether, but I haven't done that. Okay, we also have a few practice exams here. Those practice exams are not going to be very helpful because, well, they might be helpful, but they're really for a previous semester where people actually have to trace through the entire algorithm from pre to post. But in terms of the type of question, they're very similar to what we are dealing with here. So you might want to do that. If anyone is doing it, just remind me to go over the answers on Tuesday. Okay, they're already available, so you can always just click on it, try to figure out the answers, and then on Tuesday, I can give you the solution. All right, so now we move on to top-down design, which is a new topic. Top-down design, ooh, that is not good. Okay. That usually means one thing. And it has to do with appearance, in-frame, automatic, new window, open. Okay, we'll just select open. All right, let's try it again. There we go. Okay, top-down design is not going to introduce any more types of statements. Instead, it is going to introduce how do we approach the whole thing about programming, okay? So before we go any further, let me ask you just a few things that you do, normally with your other classes. Okay, so let's say you're taking an English class, English 1A, okay, the typical college level writing class, okay? And you are asked to write what is the number of pages or number of words that you normally would be expected to write in English 1A? 6,000?
6,000 words.
Okay, 6,000 words. So let's call it 6,000 words. How would you approach writing a paper to turn it in as homework or a project for a class like that? An outline. Okay, is anyone gonna do this? Okay, I'll sit down and I'll just write the whole thing from beginning to end in one single session. Some people might, okay, but why do you think most people do not write papers like that when it's like 6,000 words or more?
Because it's insane. Because it's insane to write 6,000 words in a single go.
Because it's easy to lose track of the structure of the paper when you try to do something like that. Okay? Now, I can give you an even more clear example of why we need to use the top-down design approach. One approach is, I just saw on Best Buy ads, you can buy a 4 terabyte hard drive for $180 now, so it's less than $200. Remember what I told you guys about, so what happens when you have a 4 terabyte hard drive and you can only have one single root folder? So all the files, have to put into one single folder. It might be okay if your drive only has, let's say, 300 megabytes. Because 300 megabytes these days can only store, 30 files or 30 pictures or so, or less, right? It's not a big deal. But when it's 4 terabytes, even if you are, copying entire Blu-ray DVDs, it will still be able to keep quite a few of those, right? I mean, it would be kind of hard to search through, the entire directory for a particular file. Okay, it's the same way. Okay, we need to use the top-down design so that you look at the root folder. It says, backslash Windows. Do they still use Windows as a folder? I think they do. Program files, user, and all the other subfolders. And then under user, you have the different users of the system. Under a particular user, you have, I think, downloads, documents, and so on and so forth. And then under documents, then it's up to you to decide, how you want to create even more subfolders. Perhaps one with ARC, And then under ARC, you have multiple classes or semesters first, okay? Year, semester, different classes. And then under different classes, you have different assignments and so on and so forth. Okay, so that can help you, organize all that information. With programming, it's kind of the same way because we cannot pay attention to all the different details in programming all at once. We can only pay attention to a certain number of things, at the same time. What do you think is the number of things that we can basically pay attention to in short-term memory at the same time? How many things can we track in short term?
Can you define things?
Numbers, let's say. So phone numbers. How big of a number can most people remember just by reading it once?
7.
About 6 to 7, right? With me it'd probably be 3. I mean, I'm not kidding. Long-term, short-term memory is all in single digits. But it's a small number. Okay, we can only pay attention to a very small number of things, in short-term memory. So when you translate that into programming, that means you can only keep track of so many constructs, so many variables at the same time. Okay, and that's why we want to use top-down design, because top-down design basically says you only have to pay attention to a few things at the same time. Now, if you want another example, this is really a good one. Okay, because it really illustrates what top-down design is and why it is necessary. Okay, so we'll just go ahead and look at. Okay, we'll zoom all the way out. All right. Okay. How many items are there on this map? You don't have to read the individual words. Just tell me approximately how many items do we have on this map? About 10, 15-ish. Okay. Right? Maybe not even that. So I can quite easily, if I ask you, where is Canada? Can you, okay, let's say you know nothing about geography, okay? And I say, okay, here's a map of a certain planet that we have never been to, and I want you to locate, Canada. Do you think an alien can quickly point out, oh, Canada is over there? Because there are only so many items you have to search through, right? Because there are only like a few things. You have, okay, let's start with things that are not Canada's first, right? We have Argentina, Chile, and so on and so forth, so on and so forth. And within half a minute or so, anyone can locate Canada because there are only so many things on the screen. Where's ARC? Where's College Oak Drive on this map? Okay, well, I think I know where it is. It's somewhere around here. Okay, very good. Whoops. I just moved my mouse a little bit. There we go. Okay, so I think it's somewhere over there. And then someone can say, but that's okay. That can be easily explained why we cannot see College Oak Drive. It's because this screen has a limited resolution. Okay, a single pixel is more than the area of the entire Sacramento. So how can we actually see the words, College Oak Drive, on this map? Okay, let's say theoretically speaking, I can give you a projector that has infinite resolution. Okay, the dots can be infinitely small if necessary. Okay, remember that limit, x approaches infinity? We're using that concept now. Okay, so we can have an infinitely small dot, so whatever small, however small it needs to be, we'll make it that way. Okay? Do you think you can find College Oak Drive on that map? Okay, you guys are all pretty young, so has anyone tried to locate, a particular house given a physical map, like one of those maps from AAA? Okay, so someone gives you an address, a street address, and it is in North, Sacramento. Okay, how do you find an address using that map?
The signs in the street.
The sign of the street, but how do you know where to look? The map is like this big, right? Now, most of the time, you can go to the back and find the index, and it will tell you the span, like which grids, the grids. But if it is on Madison, it's going to be a long stretch, right? Because Madison is pretty long. But it has street numbers and stuff like that to kind of help you out. But it's still difficult. Even within a single grid, okay, within a single square, it is still a chore to locate a particular street because there are typically, 20, 30 names within the little grid. So it becomes difficult to locate a single thing. But when you use it, when you use an interactive map like this, it's actually easier because it allows you to zoom in. But at any particular level, there are only like 10, 15 items that you have to identify. That is why we use top-down design, is so that we only have to focus on a few things at each level of details. If you want more details, you zoom in some more. But when you zoom in, okay, let's say you're zooming into a particular area in Sacramento. When you zoom into Carmichael, you no longer need to know anything about elk groves, right? Because they're completely different parts of the town, and you don't need to pay attention to what is in elk grove when your map is already zoomed into Carmichael. And it's the same reason why we want to write programs using this mentality, is we only want to focus on a few things at each level. Okay, we are running out of time today, so I want you guys to read the notes ahead of me, and then we'll talk about the factoring problem. Okay, so you might want to brush up on factoring as well.
Never get lost.